Hi, this is the weather on August 28th, 2005. You can see it's the temperature on August 28th, 2005. Down at the bottom of Texas and Arizona and a little part of California, it is 100 and higher. We can see it gets a lot colder as we go up throughout the states. It was only 90 to 100 through here and 80 to 90 through all of these states. Then it's 70 to 80 in Minnesota, Wisconsin, North Dakota, Michigan, Ohio, West Virginia, Virginia, Maryland, part of New Jersey, New York, and all of Pennsylvania. But these are the maximum temperatures. Now here we have the minimum temperatures. As we can see, the hottest minimum temperature is 80 to 90 on the southern tip of Florida. Then throughout the other southern states, it is 70 to 80. And throughout the states above it, 60 to 70, and it continues to get colder from 50 to 60 and 40 to 50. As we can see here, that it is relatively very warm at the bottom of Texas and warm all around here. It doesn't go down that much, but it gets cooler as we go up, as to see that it is around 75 degrees at the maximum in Minnesota, and 89 degrees at the maximum in Florida around this tip, and 100 degrees in California around this area. The air masses on August 28th, 2005. As we can see, that the maritime polar air masses are coming in this way, and the continental polar air masses coming down this way. This continental polar air mass seems to be pushing the cold fronts and warm fronts down toward Louisiana, Texas, and Florida area. The maritime polar winds coming from this way are pushing the fronts back toward North Dakota, South Dakota, Kansas, and yeah. The maritime polar winds from this way are pushing this front along, which means that we're expecting the front to continue going this way. As we can see that the continental tropical winds are pushing this way, which seem to be creating the warm fronts along the area because of the warm air getting blown this way. The maritime tropical winds coming from this way are causing some storms to be pushed this way. And the maritime tropical winds from here, coming from the Gulf of Mexico, is pushing Hurricane Katrina to Louisiana. So watch out, people living in Louisiana. We can see the maritime tropical winds coming up are causing low pressure around these areas, North Carolina and Mexico. The air masses affect the world because they are pushing fronts along as they are pushing winds. Without them, we would not be able to have the fronts and the clouds be pushed and stuff like that. As you can see on August 28th, there are lots of types of fronts. We have a few stationary fronts, like the stationary front up here, some occluded fronts, like the occluded front at the tippy corner of Canada, and a small, very small occluded front right there. So you can see we have a warm front, like right there, right there, and right there. We have cold fronts, ranging from all the way here and all the way there. And we have high pressure areas and low pressure areas. Examples of low pressure areas are places like right here, right here, right here, right here, right here, right here, and right here. Oh, this map is kind of blocking it. And we are affected by fronts because cold fronts develop rapidly and move the cold air in the way they're going. So that means we are moving cold fronts are moving this way, and we are suspecting it to become colder in this area. Cold fronts make storms and abrupt weather, so be prepared for rain around here. We don't see any coming, but it could always come. And cold fronts pass, and they usually leave clear skies, but lower temperatures and shifts of winds. So around here, we're not expecting rain, but it's going to be colder than normal. Stationary fronts, like the one up here, are cold and warm air meeting, but they can't move each other where they meet, so the water vapor forms into rain, snow, fog, or clouds. Cold fronts and the warm fronts together could bring precipitation for days. like the stationary front. The warm fronts, like right here and right here and right there, are fast-moving warm air that overtakes slow cold air. If warm air is humid, light rain or snow occurs. If the warm air is dry, scattered clouds form. The warm fronts move slowly, making rain happen for days. And it's likely to be hot and humid once these warm fronts pass. We also have a couple occluded fronts, like the occluded front there. They are when warm air is trapped between two cold masses, and they try to push the warm air, and the warm air pushes up. The ground is cold after they pass. As we can see here, we have our pictures of the cold front. The cold air is moving this way, pushing the warm air up, creating rain, and it rains and it is cold. As you can see, here's the warm front. The cold air is moving, and the warm air is coming up, creating warm air around here. As you can see here, the occluded front, here comes the two cold air masses, and they meet, the warm air is pushed up. In the stationary front, we can see the warm air and the cold air coming together, but they can't move, causing lots of rain. As we can see here, we have low pressures. Low pressures are formed when hot air comes together, so they raise. But then the hot air wants to get up, so they get apart, so they move all over the place, creating huge low pressure areas. High pressure areas are formed when high air condenses together. The high air then sinks to the bottom, but then, because the high pressure areas want to get apart, they move outward, going to the low pressure areas, causing wind. And as we can see, the low pressure area here is the eye of Hurricane Katrina. As you can see, on August 28th, we have lots of clouds. The clouds we have here are
cumulonimbus
clouds, and they are very dark because the cumulonimbus clouds bring rain and are a couple layers thick. That's rain. So as we can see, there's rain predicted around these areas. We have stratus clouds in areas such as right here, where the fronts are moving. Stratus clouds are small, thin layers of clouds that are below 6,000 feet. So, yeah. We have altostratus clouds, which are just little puffs of clouds around here. We have attocumulus clouds, which are pretty much the same thing around here. Same thing as stratus clouds that move fronts. Clouds are formed when water vapor in the air condenses to form liquid water or ice crystals. Ice crystal clouds usually drop snow or hail, and the condensed clouds drop rain. As we can see here, that storm is around this area and this area. There are lots of scattered thunderstorms around the parts. You can also see that where there are thicker condensed rains, there is more rainfall, such as 1.50 inches of rain, where we have this area, and 1.19 inches of rain over Lake Superior, where we have this area. Rainfall happens when the condensed clouds in the air need to drop their rain, so the precipitation goes down in the form of snow or rain. 2 days later, we can see that it's raining a lot more in areas like these. As we can see, there is very much rainfall over here and over here, where Hurricane Katrina came in. The continental polar from right here is blowing storms this way and down, and the maritime polars are blowing storms this way and storms this way, causing a clash of air masses, making it rain much more. Wind is created when high pressure and low pressure areas meet, causing wind to blow throughout the world. As we can see here, we have a picture of the world. We have doldrums in the middle part near the equator, which, don't really affect the U.S. that much, but they can travel toward the poles at 30 degrees north and south latitude. The doldrums stop moving and sinks, and then the air moves back toward the equator, affecting the USA around this area, because we have the doldrums coming back, making it colder. The trade winds, which are extending this way and this way, the trade winds affect the USA by pushing warm and cold air throughout the world. The Horus latitude is a wind belt that forms about 30 degrees north and south latitude between the trade winds and prevailing winds, which is right about here. Which that does is, it's just a wind belt that blows above the USA in this area, causing fronts, pressures, and such. Prevailing westerlies are these winds that extend about 60 degrees north and south latitude from the Horus latitudes. They come all around this area and will blow cold air in from the poles and warm air in from here. The polar easterlies are these winds that reach the poles about 60 degrees north and south latitude. Cold air.
Very, very cold.
So higher pressure areas send air to lower pressure areas because the molecules want more space, and then that's what creates this wind. To heat the Earth, we use 3 types of heat transfer. The sun's radiation. As we can see, it's baking the poor Earth, making it hotter around this area. We also use convection, the huge convection currents above the Earth in the troposphere that bring cold, dry air back down, making the Earth colder. But then when it gets warmer around this area, it comes right back up and, gets cold again. We also use conduction with heat transfer because conduction heats the Earth's surface from the inside and warms a couple meters of the troposphere, which really isn't that much, but it is still used. Thanks for watching.
Yeah, thanks.